Okay, so have you ever looked up at the night sky and wondered, like, what's really out there? I mean, really out there?
Beyond what we can even imagine,
Boy.
probably.
Well, on today's deep dive, we're going to be talking about a telescope so powerful it could totally change how we see the universe and maybe even our place in it.
We're talking about being able to see other planets,
Woo!
not just as little blurry dots, but with details. Like you'd see looking at the moon through a telescope.
You're serious?
Yeah, like continents, maybe oceans, even hints of life.
No way. That's incredible.
Yeah, it's a game changer.
So this is the monster scope, right? And honestly, that name, it's pretty spot on from what I've read.
It's an absolute beast.
Okay, but before we get into the telescope itself, we need to touch on SpaceX and their Starship program. You sent over some news on, what was it, Starship Flight Test 5, and it sounds like they managed something amazing with their super heavy booster.
It was a big one. So
Yeah.
instead of the booster splashing down after launch, which is pretty standard, they actually caught it in midair.
They caught it.
Yeah, with these massive robotic arms they've got on the launch tower.
Hold on, they have giant robot arms that catch a rocket falling from space.
It's wild. They call it, get this, Mechazilla.
Mechazilla.
Yeah, Mechazilla catching a rocket. It's straight out of science fiction.
That's insane. But how does this connect to building a telescope the size of, like, a city in space?
It's all about what it represents.
Mm-hmm.
So right now, just getting anything up into space, it's so expensive. Plus, we're limited by the weight a rocket can carry. Starship changes that game completely.
Okay, so we can launch more stuff, but why is that so important for a giant telescope?
Well, think about it. Traditional telescopes, they have to be folded up so precisely to fit inside a rocket.
Right, like origami.
Exactly. All
Right.
crammed into the nose cone at the top.
Mm-hmm.
Then, once it's up in space, it has to unfold perfectly.
Which seems kind of terrifying when you think about it,
Right. It's a super delicate process.
with a lot of potential for things to go wrong.
Totally. But with Starship's payload capacity, size isn't such a constraint. We could launch huge pieces of a telescope.
Or even launch a bunch of smaller pieces.
Exactly. And then assemble it all in space.
So this monster scope, I mean, are we talking about something completely different scale-wise than anything we've built before?
Oh, absolutely. Way bigger. And that's where the comparison to the James Webb Space Telescope comes in.
Okay, yeah, the James Webb, that's the big one. Well, it was the big one, I guess.
Right. And don't get me wrong, the James Webb is an amazing piece of engineering. But it is limited by its size. See, the bigger a telescope's mirror, the more light it can collect.
Makes sense.
And the more light you gather, the fainter and farther away the objects you can see.
So it's all about light, kind of like how our eyes work. A bigger mirror is like having better vision in space.
Exactly. It's like the difference between looking at the night sky with just your eyes and then looking through a powerful telescope.
Wow.
The monster scope, it would make the James Webb look like a pair of binoculars.
Okay, wow, I'm getting chills just picturing this thing. But let's talk about why this matters, other than just breaking astronomical records.
Sure.
What could we actually see with a mirror that big?
Imagine this. We could see continents and oceans on planets going around other stars.
Wait, so we wouldn't just know a planet is there? We could actually see if it has, like, oceans and continents from Earth.
That's the idea. We could maybe even see seasons changing, like ice caps shrinking and growing, or deserts blooming after rain.
That's wild.
You might even see signs of plants and animals if they exist.
You're kidding. Like alien life.
It might be possible with this telescope. It could change everything.
Okay, I need a second to wrap my head around this. We could see what alien plants and animals might look like on a planet light years away.
It's pretty incredible, isn't it?
It's mind-blowing.
And it's not even just about the pictures.
Right.
Analyzing the light from these planets, we could learn so much more, like what kind of atmosphere they have, their geology, maybe even chemical signs of life that we can't see with our eyes.
Wow. So we're not just talking about finding a planet that could have life. We're talking about actually seeing evidence of life itself.
That's the potential here.
Okay, that's huge.
Yeah.
But let's get back to the monster scope for a minute. How do you even go about building something that massive in space? It's not like we can just, like, get a giant wrench and
Just-
space.
It's definitely a huge undertaking. But the key is this modular design they're talking about. So instead of one giant mirror, it'd be made of thousands of smaller hexagonal mirrors,
Okay.
all working together. Each one could be launched separately by Starship.
Oh, okay. So like a giant space jigsaw puzzle.
Yeah.
But then how do you put it together in space? Are we sending, like, astronaut construction workers up there?
Actually, it's even cooler than that. Remember we talked about the learning rate?
Yeah.
That comes into play here, too. They're talking about using robotic systems that could build the monster scope autonomously.
So like self-assembling robots in space.
Pretty much. It sounds crazy, but we already use similar tech here on Earth for stuff like manufacturing, even surgery.
Wow, that's amazing. Okay, so we've got these robots putting together our telescope, but how do we actually use the thing? It's not like we just point this mega telescope at a planet and get a perfect image, right?
Well, that's where it gets even more interesting. Instead of focusing all the light onto one point, the monster scope would have what they call a distributed focal plane.
Okay, you lost me.
Sorry, think of it this way. Imagine you're shining a flashlight on a wall.
Okay.
With a normal telescope, you're trying to make that beam of light as small as possible, right?
Right, like focusing it.
Yeah. But with a monster scope, we're spreading the light out over a much bigger area.
So instead of one little dot, we have a bigger dot. I'm not sure I'm getting it.
It's not just any blob. It's more like a giant disk of light spread over hundreds of kilometers. And each point of light in that disk, that's where the light from a different star or planet comes into focus.
Okay, so each point of light is like a zoomed-in view of a whole other world.
Exactly. And within this disk, we'd have a whole bunch of smaller spacecraft, like a fleet of mini observatories.
So it's like having a whole observatory, but instead of on Earth, it's spread out over like hundreds of miles in space.
Exactly. And because each of these mini observatories can move around independently, they can be adjusted to study different things.
Oh, wow. So it's flexible too. That's incredible.
It gives us a level of flexibility we've never had before with space telescopes.
But even if we can build this thing, make it work, is it really worth it? I mean, it's going to be a crazy amount of money. We could use those resources for problems here on Earth, right?
It's a good question. It always comes up with big space projects.
Yeah.
But think about it. Exploring the unknown, pushing the boundaries of what's possible. It's in our nature as humans. It's how we learn and grow as a species.
So it's not just about what we might find out there, but the act of searching itself.
Exactly. And who knows what we might stumble upon along the way. A lot of groundbreaking discoveries happen by accident.
Right, like penicillin or something.
Exactly. We were looking for one thing and found something even better.
Okay, yeah, that's a good point. But even if we agree that space exploration is important, why the monster scope? Why now?
Well, we're at a unique moment. We have all these technological advancements coming together with this, human drive to explore.
Yeah.
We have Starship on the horizon, potentially making space travel way cheaper and easier. We're finding all these exoplanets, some that could even have life.
Right.
And then there's that age-old question that we're always trying to answer. Are we alone? The monster scope could be the key.
Yeah, it feels like things are lining up to make it possible. It's kind of terrifying and exciting at the same time.
That's the beauty of it, right? It's a testament to how creative humans can be. Our fascination with space is never going to go away.
Totally. Okay, I'm definitely on board with the idea now. But let's be realistic. How long is this going to take? Are we talking decades? Centuries?
It's a long game, that's for sure.
Right.
Even with everything in place. The tech, funding, global teamwork. We're still probably looking at a few decades at least.
Wow. So not something I can put on my calendar for next year then.
Probably not. But that's part of what makes these kinds of projects so inspiring, Reminds me of the Apollo missions. Back then, landing on the moon seemed impossible to most people. But within a decade, it went from science fiction to reality.
That's true.
The monster scope is that same kind of leap forward, pushing the boundaries of what we think we can do.
So it's going to be a while. But like you said, it's inspiring to think about. Even if it takes longer, we'll probably make amazing discoveries along the way, right?
Oh, absolutely. That's almost guaranteed. Think about all the things we use every day that came from the Apollo program.
Oh, yeah. Like what?
From scratch-resistant lenses to cordless power tools, those were things that came out of the Apollo missions.
Wow, I never knew that.
Yeah. It just goes to show, pushing the boundaries of space exploration, it always ends up benefiting us here on Earth, too.
That's a great point. So the monster scope, it's not just about finding alien life or learning about the universe. It's about pushing ourselves to innovate.
Exactly. And who knows what amazing tech could come out of a project like this. Stuff we can't even imagine right now.
It's kind of mind-blowing.
It really is.
Yeah.
And it's not just about us either. It's about inspiring the next generation. Think about all those kids looking at the James Webb images right now.
Oh, yeah.
They could be the ones designing parts of the monster scope in a few years. Passing the torch,
Now that is exciting to think about. So even if the monster scope itself is still a ways off, what can we be looking out for in the meantime? What are, like, the next steps to making it a reality?
Well, keep your eye on Starship and how that program develops.
Right, makes sense. If SpaceX can actually pull off cheaper space travel, it opens up so many possibilities for projects like this.
For sure. And then there's the whole thing about, like, how do we even build something this complex in space?
Yeah, the robots.
Exactly. And there are teams already working on that. Autonomous robotic assembly.
Seriously.
Oh, yeah, it's a hot area of research.
Right.
We'll probably see some cool tech demonstrations in the next few years, like maybe building space station modules with robots or testing parts for space-based solar power.
Wow. Okay, so even if the monster scope is still a few decades away, all the pieces are starting to come together.
They are. It's an exciting time to be following all of this.
It really is. Well, huge thanks to our listener who sent in this amazing topic. It was fun to dive deep into this with you.
It was my pleasure. And to everyone listening, we'll keep you updated on the monster scope as it, well, develops.
Yes. And any other awesome space news.
Definitely.
In the meantime, keep looking up and keep sending in those questions.
Absolutely.
Who knows? Maybe someone looking back at us from another star is going to be talking about their version of the monster scope someday, all thanks to the ideas we talked about today.
That would be pretty incredible.
Right. Okay, until next time, keep exploring.